Hi, everyone. So this was our do now for today, and this was the sequence 4, 6, 8, 10, right? If it was 2, 4, 6, 8, I mean, who do we appreciate? All right, so this is the term number, right? So this is the first term, second term, third term, fourth term, and then we're 4, 6, 8, 10, right? And then what did we do? Oh yeah, we use a chart to write each of the terms as an ordered pair. One thing to note, remember the first one, term number, that's our X. Our term is our Y. So normally the one on top is our X, the one on the bottom is our Y. Or if you were gonna do it this way, so if you're gonna do a chart this way, right, this would be our X and this is our Y, alphabetical order, right, top to bottom or left to right, right? And so ordered pair, remember, is we take that one and the 4, we separate it by a comma, and then we have it in parentheses. If you do not have the parentheses, it's not an ordered pair. Okay, the parentheses signify that it's an ordered pair. All right. And then we graph this guy. And if we notice right here, if I take that out, oh, I took out a point as well. And so we just plotted these points on there. Okay. And then remember, it's the X first, so it's 1 to the right and then 4 up. Okay, remember, it's just like Pokemon XY, right? So X comes first and then it's the Y, right? Notice here's the cheat, right? X is labeled already for you and then the Y is labeled for you. Same thing with the 2, 6, you go to the right and 2 to the right and then 6 up. And that where they meet, the 2 and the 6 where they meet, that's the point. Okay, that's the location, right? Think of Battleship if you've ever played that. So there's that, and this is our learning targets for today. So we're going to describe qualitatively the relationship between two quantities. So we're going to be looking at graphs, basically. Describe characteristics of graphs using mathematical terminology, and describe a real world situation that could be represented by a given graph. All right. And there were some words that we were talking about, the collinear and the nonlinear. Remember, collinear is that they can be collinear points is that, remember, co is like with, and linear is like line, you know, there's a line in there, right? So with a line, so basically collinear means you can draw it with a line. So basically you can connect all these. Are these collinear? Can you draw one straight line across them? Yeah, you can. So all these points are collinear. Okay, and if obviously if this point right here was like over here, right, instead, then is that collinear? No. Well, 3 of them are, but not the 4th one. So these points are not collinear. Okay, that's how that would work. There we go. I'll go back to normal. All right, nonlinear, obviously non meaning not, linear meaning line, so that's not a line. So we're going to be talking about those. And discrete and continuous, we're learning them right now. We're scrolling down. So hopefully you got your book. If you didn't, then make sure you go get that. But this is what I would highlight. I would use your highlighters and highlight this guy. So discrete graph is a graph of isolated points. So discrete meaning there should be no lines in there. Okay, it's discrete. That means it's broken up into points. Okay, so remember, like I had given the example of, you know, those pictures where you just do these dots. So basically, if you're lifting up your pencil and you're making points, that's a discrete graph. Okay, like a scatter plot, that would be a discrete graph. A continuous graph basically is where you can, it says right here, a graph with no breaks in it. Basically, if you take your pencil and you draw that graph in one fell swoop, you didn't have to lift up your pencil, right? That's a continuous graph. Okay. So we took a look at these graphs. Oh, let me bring them up here. So we took a look at these graphs here. Ooh, darn it. And I'm going to just bring these up for a second. And we're going to, there we go. And so we took a look. Okay, so we divided this group into 2 different groups, the discrete graphs group and the continuous groups. Okay. And so we had said that the age, and if you have not done this before, try doing it yourself. Don't look at the answers, don't cheat, right? But A, J, F, we said were discrete. And if you notice A, right here, right, see, ooh. So A, J, F. And notice all 3 of them only have points. They do not have any lines on them at all. And you're like, well, what about B? Like, it has points, but it also has a line, right? And the line that goes straight through it, which means that if it has a line in there, it's not discrete, okay? So a line can have points on it. Well, technically a line is all points, just, continuous point, right? And so, yeah, these are the three, and obviously everything else is continuous because we could draw all these with one swoop, right? All of these can be drawn. Even this guy right here, right? Can draw it in one fell swoop. Okay, so then we're going to go into another kind of categorizations. Bring this down here. Okay, let's see if I can match them up with my drawings from earlier today. Ooh, there we go. And I'm going to erase this guy right here. Oh. Okay, we're going to go back to blue. All right, and so we're going to sort these into increasing, decreasing, both increasing and decreasing, and neither increasing nor decreasing. And so I made a little bit of a mistake here in class, so hopefully you're watching this video. I'll probably tell you guys tomorrow too. So increasing, pretty easy. We're always going from left to right, okay? It's the way we read, unless you read manga, and that's right. But still, doesn't matter. Left to right, we have always already determined that that's how we're going to do it. Okay, so is it increasing? So if you look at A, is it increasing from left to right? Yeah, increasing. So, and we'll look at B. Yep, totally increasing, right? Anything else just increasing? No, it's just A and B. And decreasing, we only had the two. We had E and K. So yeah, look, see this decreasing. K, decreasing. It doesn't matter if that arrow is going to the right. That just means that it continues on that way, not that it's going in that direction. It just continues that way, right? But remember, we're always going left to right. And yes, we are, when we go left to right, we are continuously decreasing. Okay, so there is K. And then both increasing and decreasing, this is where I messed up on. It's early in the morning for me too. We don't normally talk about these because these are things that we don't talk about with increasing and decreasing that much in general. But I mean, technically. So if we look at this one, is it increasing? Yes, it's increasing and then decreasing. If we go on the other side, is decreasing and now increasing, right? So technically, yeah, it's doing both of these. So D should be over there. So that was my bad. I'm sorry. I apologize. Oh, come on. Come on, seriously. Now it's just being difficult. It's being very difficult. 1 second. I'm going to take that D. I'll do it right here. And we're going to move it over here. So sorry. Do you see another one that's like that? It's not where it should be, right? I made a mistake. Miss Lee made a mistake. So yes, definitely. If you see I right there, so it is increasing here and then decreasing there. We don't normally talk about increasing, decreasing with these ones. These are, you'll find out, they're something else. Okay, so we're going to move that back. All right, any other ones that wasn't increasing, decreasing? No, I think that was it. So F, we're looking at F. F was, where's F? Oh, right here, straight up and down. That's not increasing or decreasing. You're like, but it's going down. But if you go left to right, there's no like another point, right? So this is neither. So you can't say increasing or decreasing. Same thing with J, right? And G, let's take, where's G? Right here. Yep, it's a straight line, flat line, straight across, right? So that one is not increasing or decreasing. It's just constant, staying, going straight across. Okay. And then we're gonna, then we did it one more time, and we're gonna take this guy, and we're gonna bring it down here. And what did we say? A little bit closer so we can see. All right, so we talked about linear graphs and then non-linear graphs, right? And so anything, yeah, so linear, anything that you could draw a straight line through. And remember, a graph is a series of collinear points. And so this is what we talked about earlier, the collinear, right? So you can draw one straight line right through it. Yep. So A totally works. It is linear. B, linear. G, also linear, right? Not linear, up and down. Yeah, no, not a straight line. Not a straight line. None. J, it's not connected dot guides. This is like a scatter plot with no any pattern whatsoever, right? It's just random. Yeah, so this is not, we cannot draw one straight line through that. Not happening. Same thing, this is like a bendy one, but that doesn't matter. It's not straight. Got to be straight. F, yep, totally one. K, yes. And then L, we were like, but it's a line, but is it all straight? You're like, no, no. So we're going to leave that as that. And then we remember we talked about Greg. So Greg is going, he's on a trip. And he's on a trip from home. He looks like he's driving for a long time. So he's probably in the middle of the United States or something where there's no traffic lights, and so he's never stopped. Well, a few times. And so he's going. And so we're going to be taking a look at this guy. So I'm going to bring this back up here again. And if you take a look at here, so, and we're like, okay, we're analyzing the graph from 0 to 2. So it's this blue part right here, right? So how far from home was Greg after 2 hours of driving? He had said 0, that was like, then he didn't drive anywhere. He was just staying in his garage, right? So if you notice right here, you go all the way to 2 and you're like, well, oh, he's at 120 miles away, right? Because remember the distance, the y-axis is how far away is he from home, right? So this is actually from home. Okay. So he's actually 120 miles away from home. And how fast did Greg drive during this time? And people had said, oh, he was going 60 miles per hour. I'm like, how in the world did you get that, right? How do you know that? Well, if you think about it, and if you go 120 miles and it took you 2 hours to do that, what's your average speed, right? Plus, so you take your 120 miles divided by 2 hours, because that's how long it took you. And so that would give you 60 miles per hour. That's what it means, miles per hour, per 1 hour, right? And per, remember, means divide. So that's divide. It's one way to remember it. All right, so he went about 60 miles per hour, all right, for 2 hours. And how do you know that Greg traveled at the same rate for the first 2 hours? And a lot of people said, oh, it's because straight line, right? That doesn't change. The thing is not changing. And someone said, oh, the slope, right? The slope talks about how tilted it is, right? That's, instead of saying how tilted it is, because that's so long, we just say, oh, the slope. The slope stays the same all the way through. Let's see. If I go 60 up and then 1 to the right, I'm on the line, right? And if I go another 60 up and 1 to the right, there we go. All right. And then we're going to analyze the graph in between. So see the yellow right there? So this part between 2 and 2.5. So how many miles did Greg travel during this time? And if you're like, well, it literally flatlined. Like it's not there anymore. Like he's not getting any further away from his house, right? So he didn't travel anything, right? What was he doing? Probably eating or something like that, or going to the restroom. He had a stomach ache. All right, so he's going 0 miles. And then how fast did he travel? Same idea, right? 0 miles over half an hour. I mean, a lot of you guys would just be like zero miles per hour, right? But this is like the math for that, right? So this is the distance divided by the time. And then that's what we get. We still get 0 miles per hour, right? So he was not going anywhere. So describe the graph between 2 and 2.5 hours. And we said, well, it's a straight line. Well, technically all of these are straight lines. So we were being more specific, and we're like, well, it's a horizontal line. And if you were not there in class, and I got confused all the time. I'm like, how do you know which one's horizontal, which one's vertical? So I would get like confused. I'm like which one's which? Like which one's horizontal? And like, I know it's one of them. I just don't know which one. And somebody told me, oh, it's like, when you see the sun like this on the horizon, right? Oh, horizontal, you see the horizon this way, not this way. Like, oh, that makes sense. So I never forgot it after that. So this is horizontal. So I just said, oh, okay, I know which one's horizontal, then that means the other one is vertical. And if you want to think about vertical as being straight up and down, I think of the movie Vertical Limit, because and then it had to do with like climbing a cliff or something, like rock climbing or something like that. And so here's my person climbing. Okay, it's like spider. Okay, it just looks weird now. But yeah, this is a vertical. In case you didn't know, if you were like me. But if you were not like me, then please fast forward. All right, so that's a vertical. So yeah, it's a horizontal line, which means that there was no change. It's just staying. He's just resting, because we're talking about distance here. He's not going anywhere. All right, and then if you notice right here, so we were going to change, we're going to describe each section, right? So if you did not finish this part, I would finish this part, like pause and finish this thing. All right. Okay, I hope you paused. So, we already talked about from 0 to 2 and 2 to 2.5, right? That was the A and this is the B. And then for C, we're like, okay, we traveled more, right? Because you see there's a slope of something, right? So we say Greg traveled from 60 miles further, right? Further from his home, right? And at the rate of 30 miles per hour. So how in the world, okay, we got 60 because remember we started 120 miles away from home. And then we went to 180. So 180 minus 120, that's 60, right? So if you guys need to physically see that, 120 is equal to 60, right? And then so we would travel 60 miles. Well, how long did it take us to travel 60 miles? Well, we're like, okay, well, we started at 2.5 and we ended up at 4.5. So between 2.5 and 4.5 is 2 hours, right? So we did 60 divided by 2, which is 30. And that's how we got 30 miles per hour. All right, so he was going very slow. This is like frustrating time. Can you imagine going 30 miles an hour for 2 hours? It's like probably there was traffic or something like that, right? Or he was behind a very slow car and he had a lot of patience, right? And then so from 4.5 to 5.5, so here's the D right here. So because of that, he needed a break. So he took a rest. Or maybe he got to where he needed to go to, right? I don't know. But for 1 hour, what did he do? Right, so he took a break for an hour. So he's going, he's not going anywhere. We don't have to say his rate because he's not going anywhere. All right, so 0 miles per hour. And so now from 5.5, now it looks like he's kind of going back towards. So he's like, I'm done. I'm out of here. Right, so from 5.5 to, let's see, where is this? 8 to 8 hours, right? So on the 5.5 to 8th hour, what did he do? He's going back home or he's heading back home, right? So looks like Greg turned around. And what does he do? And traveled towards his home for I should say traveled how many miles? So this is going to be 10, 20, 30, 40, 50. So right here, 50 miles. So he traveled, I should say 50 miles towards his home at a rate of, or at a speed of, right? At the rate of, that's 50 miles. And how long did it take him? From 5.5 to 8. So that's going to be 5.5, 6.5, 7.5, 2.5. Ooh, this is going to be weird. So 50 divided by 2.5. What is that going to be? Calculator? Right, you could actually do this. It's not terribly hard. Divided by 2.5. You see it? Right there, 20. So he's going 20 miles an hour. Maybe he's like behind a slower car at the rate of 20 miles per hour. Oh my goodness, my dear, I feel bad for this guy. All right, and then so he needs to take another break because I noticed that's a break because that's a long, yeah. So from 8 to, what is this, 9.5. The 8th hour to the 9.5 hour, right? What did it do? So Greg took a break because he can't take this anymore. I can't be behind slow people anymore or in traffic for how long? 1.5 hours. Okay. And then, oh, it says when he was 120 miles from home. So was he 120 miles from home here? Nope, when he was 130 miles from home. So it's a different rest stop. So I should say when he was 130 miles from home. I like to use examples that are in the book, right? Where you can kind of taking that and just, like copy paste, right? And then G, right? And so, oh, look, now he's like booking it, right? So it looks like for like half an hour, so from 9.5 to 10. And we don't know what happened to that. So they leave us on a cliffhanger. We don't know. Does he make it back home? Nobody knows. So what happens? So Greg traveled. If I can spell traveled. Let's see. How many miles is that? 30 miles? 30 miles at the rate of 30 miles. Oh my goodness. So 30 miles, and remember it was half an hour, right? Don't say 30, okay? Because then we're gonna be in minutes. So it's gonna be miles per minute kind of thing. We don't want that because that's hard to determine a rate, especially when we're driving a car. So that's gonna be if you're dividing. So how many halves go into 30? 60 of them, right? So that's gonna be, and check if you don't believe me, check on your calculator. So he's now back to cruising at 60 miles per hour, back to his home. Okay. Towards his home, I should say. Towards his home. He's going back. He can't take it anymore. That's what I think it's gonna happen. Maybe you guys can figure that out. But so we were gonna do the same thing with the pool. Okay, it's a good thing, good practice to do. But what we're gonna do is we're gonna do this. Okay, so here, this is 2.3. This is with cups. Okay, so now Blake made this. So they all made these cups in pottery class, right? And assuming that there's a glaze that so it's edible, drinkable, not cups, drinkable cups. You can drink out of the cups, right? Because they put a special FDA approved food glazy thingy, right? You all know. So here's Blake's cup. Here's Jacqueline's cup. Here's Ryan's cup. Timothy's cup, Monica's cup, and Nico's cup. There's one cup in here that I do not want. I hope you know which cup. And I'm wondering if you know that cup. So what we're going to do here is we're going to match them up. So it says, to test the cups, hot water is poured into each at a constant rate. So you just turn on your faucet, constant rate, right? Does it fill up? Is the height of the water the same, right? Not always. It depends on the shape, right? Because sometimes when you have, one of those water, like this water bottle, is going to constantly fill up the same, right? But I would say on the top, it's a little bit slower than on the bottom. The bottom is going to fill up a little bit faster just because it's slightly gets wider as we go up higher, right? And it's a little bit skinnier on the bottom, right? So this is smaller on the bottom, which means that it's going to fill up faster, right? The skinnier it is, it fills up faster, right? Even though your rate of the water is the same. And then all of a sudden when it gets wider, right, what's going to happen? That rate, it needs to fill up more area, right? So, or volume, I should say. So it's going to fill up a little bit slower, right? So for me, fills up a little bit faster here and then slows down as it goes higher because the mouth is a little bit wider and then it is on the bottom, right? So let's try it out. So which one would Blake be? So Blake, look, it has a very skinny bottom and then it gets really, really wide, right? I don't know what kind of cup this is, but so we're thinking really, really fast and then slows down. So what does that? I'm noticing right here. So this goes it's kind of it's fast and then it slows down a bit, but this one's, it needs to be, I think this is more drastic, right? So I'm thinking C right here. It goes really, really fast and then slows down, right? The height of the water will slow down because it has to cover more, it has to fill up more volume, right? So this one is going to be Blake's right here. And Jacqueline, right? Jacqueline. So it looks like it's fast then slow, but it's not like abrupt like it was for Blake, because this one was the same and then all of a sudden, boom, it got really wide, right? Fast. This is kind of constant. So I'm thinking it's going to look like the top part of Blake's, right? So if I look at that, oh, look, the graph B looks very similar to that. So we're going to call this one, Jacqueline, if I can write Jacqueline. All right, and then, oh, look at Ryan's cup. This is the cup that I don't want. What if you notice, if you pour something in, it's going straight through. Is that cup ever going to get filled up? No. Do you see one that's like that? And do you see the one they're like, oh, they made a mistake. There's nothing. No, that's Ryan's graph. Ryan's cup will never be filled. So sad. Hopefully you don't have cups like this at home. That'd be a sad day. All right, what about Timothy's cup? Right, Timothy's cup, it looks like it's get wide, but then it gets thinner, right? Or narrower as we go up a little bit. So it's going to be slow, and then it's going to start speeding up and then go really fast at the end, right? So do we have anything like that? We only have these three. So this looks like fast and then slow, yeah. Or slows and then fast and then slow. This one looks fast and then slow and then fast. Ah, maybe this is Timothy's. Yeah, I think this is Timothy's. Timothy. All right. Because it goes up, it's going to rise pretty fast, but then it quickly gets like wider, right? And then it goes. All right. So Monica. Monica's, oh, this is a weird shape. Okay. So it's like this shape. Oh, it's kind of like the Coke bottle, right? But like much more extreme. So remember, so it's wide on the bottom, so it's going to be slow. And then it's going to what? Bottlenecks, right? Which means it's going to go fast right in the middle. And then it's going to slow back down again, right? So that does not look like E. So that's looking like F. So yep. Monica's right here. And then Nico. Wide, too skinny, which means as you fill up your cup, slow, slow, slow. And all of a sudden you got to be careful because it goes, right? So it's going to do something like this. So this is Nico right here. All right. So that's what you should have written down. So hopefully you tried that out because I think these are fine. So next time you fill up your water bottle or your cup, you know, try to notice, especially if cups in the different, if they're like different like shapes. I don't know if you have different shaped cups. My cups are pretty normal. They're just like, you know, cup. Same with all the way through. Not that fun, right? But if you notice, you can also hear this the difference, right? When you're because I can hear when my water bottle is close to the top, because that the tone will get a little higher. I don't know if you've noticed that, but you should hear it, right? And then when it's lower, it's like when you're first filling up, it's like a low sound, and then it gets higher and higher. There's like the sound gets higher, so you know, oh, it's almost done. So sometimes when I get really bored, I close my eyes and see if I can match when it's like ready to be full, and I turn it off. I check, I'm like, oh, see, that's what I do when I'm. All right, so we're gonna skip through this. This was your homework right here. So your homework right here was to do page one, practice number 1. So that's gonna be this whole section right here. All right, and that has to do with this graph right here. I'll talk to you later. Bye.